time. It's something we all experience, every second, every minute, every hour. It moves in one direction, forward, relentlessly and unceasingly. We measure it, study it, and organize our lives around it. But have you ever stopped to wonder, what if everything we thought we knew about time was wrong? What if time doesn't just move forward, but could also move backward? It sounds like something straight out of science fiction, but what if it's more than just a fantasy? For centuries, the concept of time has captured the imagination of physicists, philosophers, and thinkers from every corner of the globe. Ancient cultures pondered its nature, and, over the last few centuries, we've developed groundbreaking theories about how it works. The brilliant work of Albert Einstein, for example, completely revolutionized our understanding of time with his theories of relativity. But despite all of our advances, time has always remained something of a mystery, seemingly a one-way street. Until now. In a stunning breakthrough, scientists working at the forefront of quantum physics have made an incredible discovery, something that could turn our entire understanding of time on its head. They've observed what appears to be negative time, instances where time seems to move backward. Yes, you read that right, time, under the right conditions, could flow in reverse. This discovery challenges not only our conventional understanding of time but also opens the door to questions about the very nature of reality itself. Could this be the key to time travel? Could it explain some of the weirdest phenomena in the universe? And what could it mean for the future of physics, technology, and even free will? Before we get into the specifics, let's start with the basics. Why does time always seem to move forward in the first place? In our daily lives, we experience time as a continuous flow, from past to present to future. Things happen in an orderly sequence, we age, objects decay, and events unfold in a way that seems inevitable. A glass falls and shatters, it doesn't spontaneously reassemble. A cup of coffee cools, but it never heats itself back up. We accept these occurrences as simple truths of life, but they're tied to a fundamental principle in physics known as the second law of thermodynamics. This law states that the total entropy, or disorder, of a closed system always increases over time. In other words, things naturally move from a state of order to chaos, and this direction, this arrow of time always points forward. So, naturally, we conclude that time must move in one direction. But what if time could be more malleable than we thought? What if, at the smallest levels of the universe, time doesn't always have to follow this simple rule? That's where quantum mechanics enters the picture, a branch of physics that deals with the strange and puzzling behavior of particles at the smallest scales. At the quantum level, the rules that govern the universe appear to defy all logic. Particles can exist in multiple states simultaneously, can teleport across space, and, believe it or not, can even experience time moving backward. This is where things get really fascinating. The experiment that led to the observation of negative time involved the manipulation of quantum systems in highly controlled environments. Researchers used ultra-cold atoms and precisely tuned laser pulses to create a unique set of conditions where quantum particles exhibited behavior that was completely out of sync with our expectations about the passage of time. This was achieved through the concept of quantum superposition, the idea that a particle can exist in multiple states at once until it's measured or observed. Under certain circumstances, researchers found that these particles could actually evolve in such a way that their wave functions mirrored the past, rather than progressing forward toward the future. This phenomenon is what scientists are calling negative time. Think about it like this: imagine you're playing a game of billiards. You hit the cue ball, and instead of rolling forward, it reverses course and rolls back to where it started. That's roughly what happened in this quantum experiment, except it wasn't just a simple reversal, it was an incredibly strange and counterintuitive result. Instead of time moving steadily in one direction, it seemed to retrace its steps. One of the most incredible aspects of this discovery is its potential connection to something known as time reversal symmetry. In theoretical physics, time reversal symmetry suggests that the fundamental laws of physics should work the same way whether time is moving forward or backward. In classical physics, this principle doesn't seem to hold up. But in the quantum realm, scientists have now observed time reversal symmetry under very specific circumstances. The fact that negative time has been observed at all raises some profound and mind-boggling questions. Could this principle ever apply to larger, macroscopic systems? Could we, as humans, develop technology that allows us to manipulate time on a much larger scale? The implications are potentially endless. Although we are far from building time machines, the implications of this discovery could be revolutionary. Let's consider one area where the observation of negative time could make a huge impact: quantum computing. Quantum computers already defy the conventional rules of computing, operating in ways that classical computers simply cannot. By utilizing quantum bits, or qubits, quantum computers can perform complex calculations in a fraction of the time it would take a regular computer. The discovery of negative time could open new possibilities for improving quantum computing, particularly in areas like error correction, processing speeds, and data manipulation. If time can be altered within quantum systems, the potential for breakthroughs in computing could be far beyond our current imagination. But it's not just about technology. This discovery could also challenge our understanding of causality, the relationship between cause and effect. In our everyday lives, causes always precede effects. You flip a light switch, and then the light turns on. You push a button, and something happens in response. But in the quantum world, things can be a bit stranger. If negative time is possible, could it mean that, under certain conditions, effects could precede causes? Could the sequence of events be more fluid and less predictable than we thought? It's a philosophical question as much as it is a scientific one, and it challenges some of our most fundamental assumptions about how the world works. The implications of negative time stretch far beyond the realm of science and technology. They could have deep philosophical consequences, too. For centuries, we've debated concepts like free will and determinism, the idea that our futures are predetermined versus the belief that we have the power to shape our own destinies. If time isn't strictly linear, does that mean our past, present, and future aren't as fixed as we once thought? Could the discovery of negative time open the door to new possibilities in how we understand our own choices and actions? If the future isn't set in stone, could we influence it in ways we've never imagined? Despite all this, it's important to remember that this discovery doesn't mean we'll soon be building time machines or altering the course of history. The effects of negative time were observed at an incredibly small, quantum scale, and translating these findings into real-world applications will be a massive challenge. However, much like how quantum mechanics led to the creation of technologies like semiconductors, lasers, and MRI machines, the study of negative time could eventually result in breakthroughs that change the world in ways we can't yet predict. As scientists continue to explore the strange and mysterious nature of time, they will refine their experiments, test new theories, and push the boundaries of what we thought was possible. The discovery of negative time is still in its early stages, and many questions remain. But one thing is certain: this observation has already begun to reshape our understanding of the universe. It challenges the assumptions we've held for centuries and opens up an entirely new realm of possibilities for the future. So, what does all this mean for us? For now, it serves as a fascinating reminder that our understanding of reality is far from complete. We may think we have all the answers, but the universe has a way of surprising us. The discovery of negative time is just the beginning, one more clue in the grand puzzle of existence. And as we continue to explore the strange depths of quantum mechanics, who knows what astonishing revelations await us next? The future of time itself may be far stranger and more